Hello, everybody, and welcome. My name is Frederick, and I'm on the Spring engineering team at Pivotal. For my day job, I work on a product called Spring Cloud Services, which is packaging of Spring Cloud projects for Cloud Foundry. There are a couple of small Spring projects that I'm the project lead for. One of them is what we're going to cover a little bit today. So just to let you know what this talk is going to be about, it's going to be about running Spring apps on Cloud Foundry and how those apps consume other services that you might have running on Cloud Foundry as well. So we're going to talk a lot about apps. We're going to talk a lot about services. So hopefully everybody's by now had a chance to push an app to Cloud Foundry and kind of understand what that experience looks like, and maybe even to provision some services and see how apps interact with those. So this is going to be kind of a deep dive into how that app and service interaction really happens on Cloud Foundry. Some apps pushed to Cloud Foundry might be standalone, but that's pretty rare. It's more often that an app running on Cloud Foundry is talking to something else. It might be talking to other apps on Cloud Foundry in a microservice architecture, or it might be talking to a database or a RabbitQueue. So we're going to specifically talk about this category of app that talks to back-end services. Just to give you an idea of the sort of apps you're going to be looking at today, all the apps that I'm going to use to demo are written in Spring Boot. So we're definitely talking about Spring here. It's actually just one app I'm going to demo. And if you're talking to databases using Spring, you are probably using Spring Data. So Spring Data is in play here. And if you're looking at Spring Data JPA, underneath Spring Data JPA, you're going to have a java.sql.data source that actually facilitates that communication to the database. If it's Spring Data MongoDB, you're going to have a MongoDB driver sitting under there. If it's Spring Data Redis, you're going to have a Redis driver. So in all of those cases, you've got the Spring Data library, and then you've got some other library that is facilitating the connection to the backend data source, and that library has to be configured with the location of the thing that you want to talk to. So a host and a port and a username and a password and that sort of thing. So this configure connection parameters here is really what this whole talk is about, and how you get those connection parameters configured in to talk to one of these data services. So data service isn't actually a term you'll see in any Cloud Foundry documentation anywhere. A service on Cloud Foundry can do basically anything. Any sort of resource that you might want to provision would be considered a service on Cloud Foundry. They're managed by service brokers. There's also these things called user-provided services, which is a way you can expose things that are running off of Cloud Foundry to apps that are running on Cloud Foundry. So there are some types of services, like we have an autoscaler service on Cloud Foundry, which you provision a app scaler service instance, and then it watches what apps are doing and will scale app instances up and down based on load. So that's an example of a service that an app has to know nothing about. And in fact, that service acts on an app doesn't interact with that service at all. Another example of a service like that would be a load testing service. We have a couple of those on Pivotal Web Services. So you can provision an instance of a load testing service, and that will give you, on some cloud-based load testing tool, the ability to create a load testing plan and then run that load testing plan against your apps. Again, that's another case of a service that your app doesn't know anything about. So data services, for the purposes of this talk, are just that category of service that your app does have to know something about, that your app directly interacts with to either persist data or to send messages or to do something like that. So the typical examples of this would be, relational databases, non-relational databases like MongoDB and Redis, or a messaging system like RabbitMQ. So those are just examples of the types of services that we're talking about here among that larger set of services that might be available on Cloud Foundry. So this just shows a little bit of a screenshot. This is Pivotal Web Services, and you can see some of the services that are available there. We've got a Cloud MySQL, we have a Cloud Postgres, a Cloud AMQP for RabbitMQ, MongoDB, and then we have the Pivotal MySQL as an additional MySQL offering that's limited availability on PWS now. If you actually go to Pivotal Web Services and click on this marketplace, you would see this list is much, much longer with the autoscaler and load testing and other types of services like I mentioned. So we're just really focusing on a subset of these that your app would directly interact with. So On that first slide, you saw that you push an application, and then you can create an instance of a service. And where those two meet is when you bind an application to a service instance. And in that case, that act of binding an application to a service instance, all it really does is expose the details about that service instance to your application. Now, the way that gets exposed is via environment variables. So your application would have in its environment this environment variable called vcap services, which is a big, long JSON string. And then the first level inside that JSON string would be the name of the service that you're bound to, so there could be multiple of those in here. And then there's just some metadata like the label and the name and the plan. Your app doesn't really have to care too much about those. The important part for the app most of the times is this credentials. So you can see there, in this case, the pivotal MySQL tile. The pivotal MySQL service will provide you with both a JDBC URL and a URI. So if you were doing a non-Java application, everything except Java would just use this URI field. If it was a Go or a Ruby or a Node.js app, it could use this URI field directly. Of course, Java apps have JDBC, and they kind of have their own special URL scheme to talk to that. So if you're writing a Java application, it would be pretty easy just to do a system.getEnv, get this big long JSON string, use something like Jackson, parse that JSON into a map, and then you would have your connection string and you'd be ready to go. In an ideal world, that would be the case. In fact, especially if you care anything about cloud portability, you would find that every Cloud Foundry you went to push your app to, each service broker chooses to format these credentials differently. There's no standard for how credentials have to be exposed to applications. So the MySQL service we're seeing here, I actually shortened this list. It also provides discrete fields for host name, port, username, password, and the database name, as well as having those all combined into these URL fields. The Cloud ClearDB service that we saw might choose to only provide this URI and not provide a JDBC URL. Some other MySQL might choose just to provide the host and port and username and password fields all as discrete, and you have to combine those into a URL. Aside from that, some choose to call host host, and some choose to call it host name. Some choose to use user, some choose to use username. So if you want to be portable, it's really kind of a pain to write that code that would consume this JSON and know all the names of the different fields in which things might be exposed and which things might not be exposed. So we saw a need to write a little library just to make that much easier so you don't have to worry about reading the environment variable and parsing JSON and understanding what fields might be there and not be there. And that library is called Spring Cloud Connectors. So most of the rest of this talk is going to be at some level about Spring Cloud Connectors. And this is just a little screenshot from the project page. You can see the URL for the project page down there. It's under the bigger Spring Cloud umbrella. It's not a part of the Spring Cloud release trains because it sort of lives independently from that. But the purpose of this library is really to parse out vcap services on Cloud Foundry and to allow that information to be consumed by an application in a much more flexible way without having to worry about JSON and all that. There's actually one library that does all that for Cloud Foundry. There's another library within connectors that does the same thing for Heroku. So its architecture is really flexible. There could be another library to do the same thing on Google Compute Engine or any other cloud provider, OpenShift, whatever you want. The only two we've implemented so far are Cloud Foundry and Heroku. So it's very flexible in terms of the cloud platforms it can sit on top of. It's also very flexible in terms of the services that it knows how to parse the information from. So the services that the core library supports out of the box are the ones you see here, a set of relational databases. MongoDB, Redis, RabbitMQ, and SMTP-based email is in there also. But it also can be extended, and there are a set of extensions that people have already written and that we advertise on our project homepage. We call community extensions. So SAP HANA is a database that you can connect apps on Cloud Foundry to. So they've written a set of extensions to Spring Cloud Connectors specifically for HANA. Same thing for IBM Bluemix. There's a whole set of services on Bluemix, separate from what you would see on Pivotal Cloud Foundry or Pivotal Web Services, and they've written some connectors extensions for that. There's one for Gemfire. There's one if your app wants to interact with Amazon S3 buckets, and this list should continue to grow over time as people come up with other interesting backing data sources that get exposed in the same way, and then you want apps to consume. Okay, so let's get out of slides here and just do a real quick demo. So I'll warn you right now, this will not be the most exciting app you'll see at this conference this week. So I'm here on Pivotal Web Services, and I have a set of applications that have been deployed out here. As you might surmise by the name, these are all really the same application with 6 different tweaks to them. So let's just see what it looks like. I'm going to bring up this first one. So the Olympics are coming up this week, and we're in Vegas, so I was thinking about gambling on odds. Not that I would gamble myself because I like my money too much, but let me see if I can type this in. But this little app just exposes a backend database, and the contents of that database is a list of the countries participating in the Olympics coming up and somebody's prediction of the total medal counts that each of those countries will have. This is an example of a small data source that we can expose via a REST endpoint. So this would be an example of something you might see a microservice. If you have a microservice architecture, this would be the type of service that would be at the very bottom of that microservice architecture. It's just a layer on top of a database that exposes the database contents via a REST API. Let me make that a little bigger. And this is an example of what the REST data that's coming back would look like. Okay, so that's all this app does. I'll show you how it's actually working. So let's see where this data comes from. This is a Spring Boot application using Spring Data and Spring Data REST. It's also using Spring Boot actuators. So Spring Boot actuators comes with this info endpoint, and I've enhanced that info endpoint with a little bit of information. And what we can see here is the database that this app is actually talking to currently is an in-memory H2 database. So there's not really a real database in play here yet. This is an in-memory database only, just for demo purposes. And I can see here that this app that I'm demoing has no services bound to it. So it's using an in-memory database instead of being bound to a real database. So let's look at the code for this application. So like I said, it's a Spring Boot application. So this is just my normal Spring Boot application main, just like every other Spring Boot application you've seen. So in this project, we have a domain class called team. So this just contains the name, the total number of medals, the number of gold, number of silver, number of bronze. So this is just an entity class to be persisted to the database. And this is part of Spring Data REST here. So I can make this interface. You notice this isn't even a concrete class. It's just an interface. And I can annotate it with this repository REST resource annotation. And then I extend this paging and sorting repository. So all of this, the repository REST resource annotation comes from Spring Data REST. This paging and sorting repository comes from Spring Data. In this case, I'm using Spring Data JPA. And then I can make all sorts of methods that let me find records in this database based on the various fields by name, by total count, whatever. So this is the only code I had to write to get this thing to talk to a database. All of that, if I go back here real quick, one of the things we'll see in this application is that it so far returned me 20 records in this result that you see over here out of a total of 80 because the default page size is 20. So if you counted, you'd see there's 20 countries over here. I could put a parameter over here that says size equals 40. Where you request that, now I'm getting a page size of 40. And you can put parameters on here to control the sort order and which fields you want to sort by, all sorts of interesting things, the number of page you want to, or the page number you want to get back. All of that is inside of this paging and sorting repository. So again, this is an interface, and I don't write any implementation of this interface. The implementation is generated by Spring Data. This is some really neat stuff. I'm not going to get too much more into how Spring Data works. There's several talks here at the conference about Spring Data and Spring Data REST. And I'll list those at the end, but I would encourage you to go to those. And then I have this little data source info contributor. So this is just the code that when I hit that /info endpoint that's a Spring Boot actuator, contributed some information to that info endpoint. Okay, that's all the code there is for this application. So if you remember back to that second slide, I think it was, we talked about you have your application code, and then you have Spring Data, and then you have some sort of connection class. In this case, it's a java.sql.data source, and you have to configure into that data source what database you want to talk to. But there's no code here that configures a data source for this application to talk to. So where did that data source come from? There is a data source running in this application that I'm showing here, but I didn't create one anywhere. So where did it come from? Well, it turns out Spring Boot has this nice feature. I guess I'll show the build file here too, just to illuminate this a little bit. So these are the dependencies I have pulled into the app. I have Spring Boot Web, Spring Boot Actuator, Data JPA, Data REST. And then the other thing you'll notice is I have this H2 database dependency in here. So Spring Boot, as part of its auto configuration, detects that I have data JPA in here, so it knows there must be a data source somewhere. But when the application starts up, there's some auto configuration code that runs that says there's not a data source anywhere in this application context yet. But I do see this embedded data source library on the class path, so I'm just going to create a data source for you and put it in the app context using this H2 database. So that's a little bit of Spring Boot auto configuration magic that works really nicely. This is really convenient when you're first building your app and you just want to test it and you don't want to connect to a real database. You want to make sure your SQL queries are right and all that. Spring Boot supports this for H2, HSQLDB, and Derby. I believe are the three that work out of the box for in-memory embedded databases. Okay, so that's all this little application is doing, and that's a little bit of explanation about some Spring Boot auto configuration magic. So let's show my second app here. Yes? Okay, good question. I should have shown that. Yeah, and feel free to jump in with questions. So the question is, where did the data come from? So Spring Boot also has this feature where I can create this file called data.sql, and I just put it in my source main resources, and this is the SQL that the database was loaded from. Excuse me. So in this case, it's all static SQL that I'm building up here. You can also drop a schema.sql file in here, and that will run when the app starts up as well, and it'll build the database schema. In my case, I've actually configured Hibernate. I can show that here too. I've configured Hibernate to automatically create the DDL based on the object model. So I have this team class here, and Hibernate ORM knows enough to take this team class and deduce the schema from that and then create the schema in the database. So I don't have a schema SQL in this case. Good question. Yes? Yeah, you're asking about connection pooling and how that works? We'll get to that towards the end. That's one of the things I'm going to show later. Okay, so I'm going to show my second app here, and it's actually not the second app, it's the exact same app, the exact same jar file pushed to Cloud Foundry. The only difference is when I pushed the app this time, I bound this MySQL database to it. So let's go run this version of the app and see what that looks like. And this time I'm going to just go straight to this Teams URL, which is the REST API that's been exposed. So again, I have exactly the same data. Here's the list of countries and their predicted medal counts. Excuse me. So the app looks exactly the same, but I'm going to go to this info endpoint again and see what its data source looks like. And here we have a MySQL JDBC URL pointing to this host running MySQL. So in this case, this app is talking to a real database, and it's this database that was provisioned by this MySQL instance here. So it's the exact same jar file, exact same code. Once again, there is no data source defined anywhere in my application. So how did this MySQL data source magically show up in my application? You going to give me the answer? Or you?
No, did you
okay.
include the MySQL driver?
I didn't, and I'll show you why. Because magic is happening here in this case. So let me explain to you what happened here. When you push your Java application to Cloud Foundry, this Java Buildpack runs and it stages your application. What that means is you push your app to Cloud Foundry says, hey, this is a Java application. I can tell because there's Java class files in it. So I'm going to hand your jar file off to this Java Buildpack, and it's going to download a JVM, download some other libraries, drop the JVM into the container, and then tell the JVM to run your application. One of the features that's in this Java Buildpack is this auto reconfiguration functionality. So what this code did, you can see the picture at the bottom, the Java Buildpack, when it staged my app, it dropped in this Java Buildpack auto reconfiguration library into my application's class path along with the contents of the jar file that I pushed. What this auto reconfiguration library does is implements a Spring Bean post-processor that looks at the services that are bound to your application and looks at the beans that are in your application. And in this case, it said, I see a relational database bound to your application. I see that you have a data source bean in your application, which is the in-memory data source bean that was provided by Spring Boot from the previous example. I'm going to swap out that in-memory database data source with this data source that I'm going to create through Spring Cloud connectors. So that's the Java Buildpack auto reconfiguration. So the key points are here is that it's swapping out beans. There has to be a data source bean already in your application somehow, either through Spring Boot auto configuration or some other means. And there has to be a service bound to your application of a type that the Buildpack auto reconfiguration lib knows about. If those two things are true, you'll get a swapping out of beans. So this functionality in the Java Buildpack is automatically enabled anytime that the Java Buildpack detects any Spring libraries in your application. So if it detects it's not only a Java app, but a Spring app, then it'll drop this auto reconfiguration library in there. This auto reconfiguration library uses Spring Boot to do all of the work that it does. And you'll see what that looks like in a little bit. There are some limitations with this Buildpack auto reconfiguration. One limitation is you can only have one bean of each of these types in your app. So if you have an app that's talking to two different relational databases, auto reconfiguration code will say, I don't know how to handle that. I'm not going to auto reconfigure anything. I'm going to take a pass on this one. So that, in terms of types of service beans, all relational databases are considered the same. So if you had a MySQL and a Postgres in the same app, it wouldn't be able to swap those out. Otherwise, MongoDB, Redis, and Rabbit are the other types. It's limited in the types of services it can support. It can only support these ones you see up here. So all those connectors extension libraries that I mentioned, SAP HANA, Bluemix, Gemfire, Amazon AWS A3, it doesn't know how to do any auto reconfiguration of that. So that's another limitation. And the third limitation is you can't customize any of the connection details, so like connection pooling values and things like that. You can't tweak any of that. This can be disabled. The functionality is automatically disabled if it detects any Spring Cloud connector classes in your class path. So the thinking there is if you're manually including connectors in your code, then you don't want this auto configuration stuff to happen. You're going to do it manually. Or you can explicitly disable all this Buildpack magic by setting this environment variable on your application. Okay, so that's first way that auto reconfiguration magic can happen. Okay, let's go on to the next example. Okay, let's go to this app called Auto. So So this is the point at which the demos are going to get less and less exciting because all the interesting stuff is what's going on underneath. So I see the exact same data coming back. And if I hit the info endpoint, oh, let me answer your question, Scott. There was no JDBC driver in my application because the Buildpack also dropped a JDBC driver onto my class path. That's the two things that dropped on, the auto reconfiguration library and the JDBC driver. So in this case, I'm still getting a data source that is of type MySQL using the MariaDB driver. And I could see that my URL is to that same bound service because this app is also bound to the MySQL here. And there is a little bit of code change to this version of the application. And that code change looks like this. I've added this dependency, which is the Spring Boot Starter Cloud Connectors library, which pulls Spring Cloud Connectors into your application. If you remember a second ago, I said one of the ways that the Java Buildpack auto reconfiguration is disabled is if it sees any connectors libraries, any connector classes, I should say, in your class path. So by adding the Spring Boot Starter Cloud Connectors, I've added Spring Cloud Connectors directly in my app, and that tells the Buildpack to back off and not do its reconfiguration. At that point, I do need to put a JDBC driver in my application for whatever database I want to talk to. This one still has the H2 database in there, but it's not actually being used in the case of this application. Okay, so that's the only difference between the previous version of the app and this version of the app. So what's actually happening there, I still have no code anywhere in my application that's creating a data source. So somehow a data source got magically created in my application without me doing anything. So here's what happened there. We talked a minute ago about Spring Boot doing the auto configuration of the in-memory data source. This is a similar mechanism that's happening here. If I have that Spring Boot Starters Cloud Connectors library in my class path, that enables some additional Spring Boot auto configuration. And what this auto configuration does is, again, it looks at any services bound to your application, and it looks at Spring Cloud Connectors to see all the types of services that are in connectors, and it will, instead of creating an in-memory database, it will create a data source of the appropriate type using connectors. So this is a case of Spring Boot directly calling Spring Cloud Connectors to do a similar sort of auto configuration to what the Buildpack is doing. But one really important distinction here is, in the Buildpack case, Spring Boot was introducing a bean, the Buildpack was swapping that bean out, so you get some bean swapping going on there. In this case, the Spring Boot auto configuration is able to apply a lot more intelligence and say, I'm going to disable that in-memory database creation because I know I have another option here because there's a service bound to my application. So it's a little bit more of a sane approach than creating beans and swapping beans and all that. Just by, like I said, just pulling in the Spring Cloud Connectors library is all you need to make Spring Boot do this magic. And of course, it disables the Java Buildpack auto configuration. So you may be wondering at this point, why do these two mechanisms exist when they seem to be kind of similar, and maybe the Spring Boot one is a little bit more sane? The answer is for historical purposes. Going back to the very early days of Cloud Foundry V1, as we call it, had this ability to do the auto reconfiguration, and in my opinion, its only real value is in demo mode. So you can go to a user and say, you've got this Spring app that has a data source in it, just push it to Cloud Foundry and bind a service to it, and it'll magically work. That's really the initial reason that that was added to Cloud Foundry a long time ago and why it then carried forward to the Java Buildpack. If Spring Boot would have existed way back then that Java Buildpack auto reconfiguration probably would have never been built. There wouldn't have been a need for it. So it's really just kind of there for historical purposes. I have no reason to think it'll disappear at any time in the future, but it might disappear because it's really not that valuable anymore given Spring Boot and how much the additional benefits that Spring Boot has. But there are some limitations to the Spring Boot approach also. It again only supports one bean of any given type. So you can't use this approach if you have more than one bean of a given type in your application. And you still can't customize the connection pool and other interesting details like that of a service instance because you don't have any way to kind of customize that. So there's a way to disable this Spring Boot auto configuration if you don't need it. It's automatically disabled if you instantiate a class from connectors directly in your application. So one of the core classes that comes out of Spring Cloud Connectors is this class named Cloud. If you've done anything in your application to manually instantiate a bean of that type, then Spring Boot will say, you're taking over doing this configuration on your own. I'm not going to do any auto configuration. I'm going to get out of your way. It can also be disabled manually by setting this Spring Boot property in your application, and you can make it back off in that case. Okay, any questions so far about the two forms of auto configuration we've seen? Yeah.
I saw you mentioned connecting to a number of the different databases.
Mm-hmm.
Do you know how to connect it to the code base? Any information for code
Okay. So the question is, we've talked about a few different types of databases. Is Couchbase in that list of databases that this knows how to connect to? The answer is not yet. I don't know of we saw that list of connectors extensions at the beginning, like for IBM Bluemix and Gemfire and S3. Nobody's written an extension for Couchbase yet. It's a pretty small amount of code. There's pretty good documentation on how you write those extensions. It ends up being like 3 or 4 Java classes you have to write. You basically parse out the VCAP services information, and then you have to tell the connectors library how to create a bean of the right type. So it doesn't exist yet. It would be a small effort for somebody to write that, and then it could be contributed as one of the community extensions. There is some work underway to support Cassandra, and I think maybe Elasticsearch. Those are the two that I've heard people are working on. So Couchbase could certainly be another opportunity there. Yes? Yeah, so one version of it would be, I'm not sure what the other version example.
My version, we changed the DB configuration.
Okay, so you're talking about like what if the schema changes? Yeah, that's all on your application to figure out how to handle schema changes and how to do like backwards compatibility. The Spring Cloud Connectors library is purely dealing with how do you get that connection string out of the Cloud Foundry credentials into your data source. At this level, it doesn't really deal with schemas and how to do migrations and things like that. I think the way that most people would do that these days would be with things like Flyway or Liquibase and things like that actually know how to do the schema migrations forward and backwards. And Spring Boot and Spring Data have really nice support for that. Part of the Spring Boot auto configuration is if it detects Flyway is on the class path, that could do some auto configuration with that. So those looking at Flyway and Liquibase and things like that would be the place to start on figuring out how to do that. Okay, so let's go to the next demo. Now we're going to start to get to some of the questions about how you do the connection pooling and things like that. So this is the next version of our application. It is going to be functionally identical. Still have the same data coming back. I'm going to hit the info endpoint again, and in this case I've added a little bit more information to the info endpoint just to show a point. So in this case we can see that there is some connection pooling set up. Actually all the previous examples with the Spring Boot auto configuration also had a connection pool set up. I just wasn't showing those details. In this case we have a minimum pool size of 0, a maximum pool size of 4, and a maximum wait time of 30 seconds, 3 seconds, whatever that number means. So let's see what this code looks like. So let's go to the manual. So everything about this version of the application is the same as the previous one we saw. We're still have cloud connectors pulled in. There is one additional class here, and that's this database config class. So this class is marked with the @configuration annotation, which means Spring is going to call it at startup and expect it to contribute beans to the app context. The bean that this one is contributing is of this type data source. So this is the first time in this talk where we've seen the application manually doing anything involved with the data source. In this case, all it's doing is explicitly calling the Spring Cloud Connectors library and saying, I expect to have a relational database service bound to my application. I should be able to have a data source that's populated with those connection details. Go make all that happen and hand me a data source back. So this is what you would do if you wanted to manually take over any part of this data source operation. In this case, it's not really doing anything more than the auto configuration was. But we'll see how you can use this power to do a few more things. So again, we're now talking about manual configuration where your application is taking complete control over that connection configuration, but it's still an extremely small amount of code that you're having to write. It does allow you to do this customization of the connection parameters. And this is the point that where you get past that limitation of only having one service of each type. Now let's actually go look at the next example now. So this is the custom example. I'm not going to bother showing you the teams again. I'm just going to go straight to the info endpoint. So the only difference between this app and the previous one is now my minimum pool size is 2, my maximum pool size is 10, and this has changed from 30,000 to 60,000. And this is because my app has now taken over customizing what these pool parameters look like. And in the code, what that looks like is just a tweak to this database config class. So now instead of just saying connection factory, get me a data source, I'm providing some configuration for that data source. So one of the things I can do is say, I want my pooling parameters to be a minimum pool size of 2, a maximum of 10, and I want a 60,000 wait time. So this is how you're taking that over and entering these values yourself. There's also this connection config where you can enter sort of arbitrary fields that might apply to your JDBC driver that you want to customize. Exactly what these classes look like are different for each type of service you want to connect to. So if this were a RabbitMQ service, instead of calling connectionFactory.dataSource, it would be connectionFactory.RabbitMQ connection or whatever the name of that method is. And there would be some different objects that you could create to pass to that. So the documentation is pretty good about telling you what the configuration classes you can create are that you can pass to these connection factory methods to customize all these different aspects of the bean that's being created. Does that answer the question about pooling customization? And okay, so the question I think is, so now we have pooling parameters, what's actually doing the pooling? So this data source that's being created here might be a Tomcat pooled data source or an Apache Commons DVCP2 connection factory. I think I got that acronym wrong. So Spring Boot will look for any of those pooling libraries on your class path and will automatically configure those. So I guess I'm not showing the class that's getting created. Well, I can show that here. And let me go back to this data source info contributor. This data source class that's actually getting injected here is org Apache Tomcat JDBC pool data source. I just happen to know for this application that that's what's on my class path and that's the type of data source that's being created. So the Tomcat libraries are doing all that connection pooling in this case. Yeah, you can, connectors and Spring Boot both support Hikari and this Tomcat library, and there's an alternative Tomcat library, and the Apache Commons. Those are the 4 that are supported by both Boot and the connectors library. One of the Tomcat ones, I'd have to go back and look again. Well, let me answer this question. I think the Spring Cloud connectors is the best way to answer it. So the question is, which of those libraries is most widely used? And I think the answer depends on whether people are customizing it or just using what comes out of the box. I'm sorry, I'm looking for the documentation. That's not what I want this one. Okay, so here in the documentation for connectors, there's similar documentation in Spring Boot somewhere. In the Spring Boot side, it'll tell you here are the types of data sources that Spring Boot will look for in the class path and automatically create for you. So it's the Apache Commons DBCP and DBCP2, Tomcat DBCP, the Tomcat JDBC connection pool, and Hikari CP. So the answer to which one is most widely used is kind of a hard question, because in cases like my app, I just said I want Spring Boot Starter Web, and that automatically pulls in embedded Tomcat. Because I pulled in embedded Tomcat, I'm getting this Tomcat DBCP. So that's the easiest thing to do, but people who really look at this stuff, I think will tell you that that's one of the more poorly performing implementations. So when people start to get further along and getting close to production and starting to do tuning, I think they're most likely going to fall down to one of these other ones and explicitly add, all you would have to do to enable one of these two is just to, for example, add Hikari CP to your class path as a dependency to your application, and now that's the one that's going to get picked. So I'm not really sure which one most people use. These are the options, and those are the things that Spring Boot and connectors will auto-configure for you. Okay, let's see where we are here. So again, the picture at the bottom just shows that there's now nothing in between your application and connectors. There's no magic going on. There's no auto configuration. You're completely in control of what happens. So this one, I just put this example on a slide. I've talked about how most of the all of the auto configuration options have this limitation of you can only have one service of the same type. If you had some legacy type application that connected to multiple databases, that's not really the sort of thing you would do in a microservice architecture, but in some older apps, you might have that scenario. This is what that would look like with connectors. You just have to pass this additional parameter to that data source method and give it the name of the service that you've bound to your application. So that's you telling the library, I know I've got two, I named them differently, and how I want those bound service with the given names mapped to a data source, and then other places in your app, you'd have multiple repositories that they would get injected into and things like that. And then if you were doing the connection customization, that would be a second parameter that you could pass to these methods. So you can use both of those together. So back to the in-memory database option. That's a nice thing to do maybe when you're early on doing testing. You might even want to keep doing that when you're doing local testing. Or you want to locally just run your app real quick and write from your IDE and connect to an in-memory database and test it. But then when you actually push it to Cloud Foundry, you want it to use a bound service. One of the other things that the Java Buildpack does for an application is it sets this Spring profile called Cloud. So that's the way your app can tell that it's running on Cloud Foundry, and then you can use Spring Bean profiles to say if I'm running locally, which would be the default profile, I want to go ahead and use create my own data source for a local database or use in-memory or whatever. But if I'm running on cloud, I want to go ahead and invoke connectors and connect up that way. Okay, and then there is one more option. And I don't think I even need to show the code for this one because the code, well, let me go ahead and show that. Just to prove that everything is above board here. So in this case, I don't have that database config class. I do still have connectors in the class path, but I have set this cloud enabled property to false, which should turn off Spring Boot's auto configuration. And then I am explicitly setting in my Spring Boot configuration what the data source URL is, and I'm using this placeholder. So this is something that Spring Cloud connectors will also set up for you. Let's go to this version of the app and I'll show you what that looks like. Actually, I could go to any version of the app and show you. Let's just go to this one. So if I hit this env endpoint, which is also provided by Spring Boot actuators, that's going to show you all of the property sources that are injected into your Spring application. So I'm going to go to the bottom, and I will see this cloud property source that's got a set of properties inside of it, including cloud.services, which will list all the services you have bound to your app. And this one I named TeamsDB, and the connection and the JDBC URL. A port wasn't set in this case because it's all on the URL. And then this will give me some other interesting information about the application. You can see I actually get the URL with two values here, JDBC URL and URI. It'll tell me the connection scheme. It's actually showing me this two different ways. It's showing me with the TeamsDB in there, which is the name of the service, and then it's also giving it to me with the type of the service. So this is just an attempt by connectors to give you a bunch of properties. If for some reason you wanted to inject these properties directly into your application, you could. In this case, I'm doing that using the Spring Boot property mechanism. You could also have @value annotations on bean classes and get them injected that way. So is there a good reason why you'd want to do it this way? Not really. This is everything we talked about before have been sort of levels of auto configuration and getting the auto reconfiguration to back off. This is really just another option that if for style reasons or preference reasons you felt like doing this, you can. But there's really no discernible advantage of doing this. A few disadvantages are that it's back to only supporting one bean of each type. And if you start doing this, you now have to be aware of how the different types of services expose their credentials. So you're having to know if it provides a JDBC URL field or just a URI field. And you have to either know what type it is or know what the name of it is. So now you're a little bit more tied to exactly what that bound service looks like in this case. So it's, I would say, less flexible and not really the way you want to go, I think. But it is out there, so you can do it if you need to. Okay, just a few more things to mention. There's a blog post that Dave Sire wrote a little while ago. I guess the date's in here. Over a year ago. I didn't realize it had been that long. It covers a lot of the same content that I've been going over here, but in more of a blog-like form, and it's got some things you can kind of try and play with. In some ways, this presentation went a little bit deeper. In some ways, Dave's blog went a little bit deeper, so you can go read his blog and get some more information. This demo app that I've been showing is on GitHub. At this URL, I need to add a README and some instructions on how to push it and stuff like that, but it is out there. And then I'll throw a plug-in for one other application. This little Spring Music application has been around for a while. And it was built as a test application, so it can connect to either a JPA data source or MongoDB or Redis. And it'll connect to all the various relational databases like MySQL, Postgres, DB2, whatever. So if you want an app that is an alternative to this demo app from this presentation that does Mongo or Redis or something else, you can go check that app out and see how it's doing its configuration and things like that. And that's all the content I have. I did want to mention a few of these talks since I spent so much time on Spring Data and how it's doing some of its stuff. Here's some other talks that if that's of interest to you, you might want to look at. The first two, Introduction to Spring Data and What's New in Spring Data, have already happened. So you'll have to wait for the recordings for those. This last one, Advanced Spring Data REST, is going to get more into the REST part of this. So not just how the database gets exposed, but how that gets actually transformed into REST. And if you noticed on these UIs I was showing here, there's this HAL browser that's coming up, and all of this JSON that's coming back is nicely formatted as HAL. Let me go to this one. So Oliver will talk a lot about why HAL is important and how you get Spring Data REST to do this HAL with the links and all that sort of stuff. So that should be an interesting talk if that sort of thing is of interest to you. Okay, and that's all the content I have. Does anybody have any other questions? I think I'm giving you some time back if nobody has any questions. All right. Yes, Scott.
If I bind multiple data sources, I still get beans created in my context format. I don't have to create the abstract configuration files.
No, if you,
I just do that.
so if you're not doing any of the manual configuration, if you're not doing any of the manual configuration, then both in the Java Buildpack case and the Spring Boot auto configuration case, both of those will say there's more than one bean of this type and I don't know what to do with it, so I'm going to back off and not do anything.
Okay, so then to get access to both of those data sources, I would need to extend the abstract cloud config
Yes.
and then create the data sources for each.
Yep. And in both cases, that's nicely logged. The Java Buildpack auto configuration, if you look in the logs, it'll say, for this reason, I chose to skip auto configuration for the relational database, and Spring Boot does similar logging, so you can see that it's backing off and deciding not to do anything and why. And I think that message in the log says, I expected one bean or one service of type relational database, but I found two. I give up. I don't know what to do. You're on your own. Mm-hmm. Yeah, so the question is, there's a lot of stuff going on between that domain object of Teams and how that's actually coming in. So the layers there are Spring Data JPA, which uses JPA, obviously, and by default will pull in Hibernate. So Hibernate is doing a lot of that object to relational mapping underneath Spring Data JPA. The docs are pretty good for that in Spring Boot. There's a whole section of the Spring Boot docs that talks about how all that Hibernate and JPA and all that stuff gets configured automatically and how you can take over some of that. So I would recommend one of these Spring Data talks that are mentioned here. They'll get a lot deeper into how that works than I will here. So. I'm sorry? Yeah, so if you look at, I think this is the answer to your question, I'm not sure. If I look at this build file again, if I were to, the Spring Boot starters are basically a way to just depend on one library and get a whole bunch of things pulled in. So if I were to actually go look at the dependency graph for this application, you'd see a whole bunch of libraries getting pulled in, some of them just by this starter data JPA. And that would include Spring Data JPA and Hibernate. And if you want afterwards, I can bring up the dependency graph for this application in my IDE and show you what that explodes out into. But that's basically what Spring Boot starters are for. It's like, here's one library you can depend on. It's going to bring in everything you might need to do this one thing like JPA. Okay, thank you very much. I'm going to stick around up here. We've got some more time, so thank you.